Okay. So any general solution to Maxwell's equations, if I have an electromagnetic field, what is the general solution? The general solution is for a definite energy, and the energy of the radiation is fixed, some value is there. In the source free region, if I take it, then it can be expressed as a linear combination. Idella particular solutions. So that is to say, I have particular solutions and then general solution. ನಿಮ್ಗೆ ಯಾವಾಗಲೂ ಈ ತರದ ಕನ್ಫ್ಯೂಷನ್ ಇದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಬ್ಯಾಕ್ ಟು ಯುವರ್ harmonic oscillator example and then think about it. That is what I am trying to tell you here is, if you have, this is a solution. Okay. This is a solution. Electric field solution for the Maxwell's equation. L, for each value of L and M, you have a solution. ಇದೇ ತರ ಇದೂನು ಒಂದು ಸೊಲ್ಯೂಷನ್ ಆಗಿರುತ್ತೆ. ಇದು ಕೋಎಫಿಷಿಯಂಟ್ಸ್, ಜಸ್ಟ್ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ ಆ ತರ ಇರುತ್ತೆ. ಸೊ ಇವಾಗ ಇದು ಇದೇ ತರ ವಿ ಹ್ಯಾವ್ ಅಡಿಷನಲಿ we have magnetic field also. Now the question is, this AELM and BAMLM, e coefficients, they characterize the source. Idu solution, so fine, but source properties illirutte. But adeno nimge gottilla ivaga. What are these coefficients anta gottilla. So what we try to do is we call them as amplitudes for the electric type multipole, magnetic type multipole. Adike these are what are called as multipole moments. So sorry, multipole amplitudes. So then what I will do with this kind of a situation is, I want to ask how to determine source dependence. That is, how does it depend on the source? That is the question. In order to know that, I told you we need to determine these amplitudes. I want to know how these dependents depend on the properties of the source. That is, this is important for me. So this is what gives you, that is, I have some charge distribution. Let us say I have some charge distribution. Charges are distributed. There may be some current. I am an observer sitting here and I do see some electromagnetic radiation. I detect electromagnetic radiation. Let me say it is a gamma and let me say this is a nucleus for now. So then this nucleus is emitting the radiation. So the radiation should carry properties of the nucleus. Nuclear properties should be hidden in this gamma, meaning that this gamma is an electric field. Gamma is an electric field and also a magnetic field because it is a radiation. We already always tell you that any radiation is characterized by electric and magnetic fields, and this electric field, it is a combination of all the solutions AELM and EELM, etc. This is an electric field, but coefficients are here. That is more general. So I have to know what are these coefficients, because this source is emitting it. For example, if a sodium vapor emits radiation, sodium lamp, that is yellow in color because it is coming from sodium. Similarly, a nuclear radiation, gamma, it should carry a property of this which may not be visible for us. We need to learn what are the properties of this. So in order to do that, I told you, let us solve the Maxwell's equation in the region of the source. That is what is the only way that we have. So I will say that, fine, we are doing this and we have to solve Maxwell's equations in the region of the source. You may not be aware of this kind of Maxwell's equations. Idu gottidiyಾ, displacement vector hakbit bariyodu. Do you know Maxwell's equations in the region of the source? ಈ ತರ ನೋಡಿದೀರಾ?
Yes, ma'am. Yes, ma'am.
You know displacement vector ಅಂತಂದ್ರೆ ಏನು? Just I don't need anything else for now. I need you to know Maxwell's equations in the region of the source ಅಂತ ಬೇಕು. Material presence of the matter ಹೇಗಿರುತ್ತೆ ಅಂತ ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. If we know that, then I will say, fine, we know it. And what is the source property here? Source ಅಂತ ಅನ್ನೋದನ್ನ we characterize with a, classically source is characterized by rho of RT. and current density J of RT, and also there is a magnetization ಅಂತ ಒಂದಿದೆ ಇದರಲ್ಲಿ. ಈ ಬಂದಿಲ್ಲ ಅಲ್ವಾ, ಬೇಡ ಇವಾಗ ಬೇಡ. So I will just say these two characterize, that is, wait 1 minute. So I have rho and J, they are characterizations of our radiation. If I say these are our characterization, then how do I go ahead and talk about solutions? That is, I need to find the solution. What is solution? Electric field beku, magnetic field beku, as a function of R and T. I know this electric field and magnetic field in the source free region, but illi source itkond madidre en barutte anta idea beku namge. So then I will tell you how do I get what is our electric, that is this, how do the amplitudes depend on the source. Adu gottagutte namge. We should remember what we are trying to do, then only we will be able to go ahead. So let me say I have to determine it. So we know that this is explanation again. So we have displacement vector, which is defined as epsilon naught E plus a polarization part. The polarization part, we are going to ignore it later on, because compared to electric field, P is very, very small. Polarization ಆಗಲ್ಲ ಅಂತ ತಿಳ್ಕೋಬಹುದು. ಅದನ್ನ ಯಾರು ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ those who calculate it, they know what is the strength of the polarization, what is the strength of the electric field in any radiation. So then we can ignore it. Right now, you just take it, whatever is the definition, fine. And I have divergence of P is equal to minus rho B. Rho B is called the bound charge anta karitare. Free charge anta ondide, bound charge anta ondide. Total charge is free charge plus bound charge. And similarly, dou P by dou T is called bound current density. And then we do have, these are all already known in the sense you are familiar with in these things in your electrodynamics class. So what I am trying to tell you is curl of this JB is what is called as magnetization. That is one more characterization. So these are something properties which we already know for the source. So we know what is rho, what is J, etc. So then what I will do is, this I had already told you. So now we will say we have a fixed energy radiation for every rho, J, P, M, everything. I have to substitute a e to the minus I omega t kind of a time dependence. That is, I have time dependence given by e to the minus I omega t. That means if I have a rho of RT, I have to write it is rho of R multiplied by e to the minus I omega t. R dependence is this, and then there is a e to the minus I omega t. T is factorizing. Time dependence is factorized. If it is of that sort, for everything, for rho, J, P, everything has that kind of a dependence. Then what I will do is, I have basically, I have Maxwell's equations. We can simplify it, is what I told you. When I simplify it, I had asked you to derive this equation when you simplify in the last class. Have you done it? Try madidira. See, these are the questions which will appear for your examination. That is, this is, so let us say this is for some 5 marks. Write Maxwell's equations and we assume a fixed energy electromagnetic radiation. Show that this is what is given. Then you have to substitute and use what you have to use with the given information. So this is one assignment. I will give you set of questions which are important. So that is, you have to do them later on. So right now I will just say, fine, we will go ahead. I am assuming this. So what is important for me? I also told you we define something called a divergence free field. Divergence free is to say, I want to say divergence. This is a vector dot product with E prime of R. That is equal to 0. This is what I am telling. If you define like this, you will get it. And I leave it as an assignment. Again, this is like a examination short question, 5 mark kind of a question. So what is that you have to prove? I had asked you earlier. So if you haven't done it, you do it and submit it later on. So E prime, if it is this, prove that divergence of E prime is equal to 0. This is what I have asked you. Hint, you have to use the continuity equation. What is continuity equation? For any electromagnetic source and charge, I have divergence of J of R comma T plus dou rho by dou T R comma T, that is 0. So, but rho of R comma T for a fixed energy, it is rho of R e to the minus I omega T, this rho of R T, and J is also J of R e to the minus I omega T. So now you have to substitute it, and what do you get? You will get divergence of J of R, that is, I killed time dependence. So I get I omega rho of R, that's what I get. So I have to substitute that when I simplify. That is divergence of E prime. If you take divergence of E prime, that is 1 over epsilon naught is there. Divergence of D is given by Maxwell's equation. What is divergence of D? Plus I have a I by omega and J of R. Divergence of J is, I have to substitute I omega rho of R. Now I is, here it is minus rho of R. So what is divergence of D? What is divergence of D? Maxwell's equation. Anybody? If
Rho.
not,
Rho, ma'am.
divergence of D is
Del dot T rho.
not rho. Okay. So I get rho of R minus rho of R. It is 0. I have indicated to you how to prove that divergence of E prime. Divergence of E is not 0, but divergence of E prime is 0. Why am I trying this? Earlier in the source free region, I know how to do it. Correct? I do know how to do solutions, how to get solutions in the source free region. But if it is not in the source free region, how am I going to do it is the question. So let us check this, just a minute. It's moving on. So let me check. Okay. Oh, divergence of D is rho. So what have I got here? D is this. Just a minute. Here I have a 1 over epsilon naught. Whole thing is 1 over epsilon naught. D of R plus I omega. I am checking whether I have written it properly. So if I write a divergence of D, it is rho, and divergence of J is, I said it is correct. This is not rho. I made a mistake when I was explaining it to you. So please make a note. You have to use whatever is given to you. Whatever I have written is correct. So you will get this divergence of E prime is 0. Okay, for that you have to use these equations. Oh, it is written here. Anyway, I didn't see it, so I was confusing you. So all right, once I have this, what is that I am trying to do? So remember that some remarks are that in the source free region, I have E prime of R is simply E of R because I don't have a displacement vector is going to be simply E of R. There is no polarization and all that. I don't have anything. And curl of E prime is some value. Let us not bother about all this. I don't expect you to remember these things unless it is given, but I have to know how to solve it. Basically, I have an idea about what is the solution of these equations in some way. So I will just continue with that. So now I will get, in terms of divergence free electric field and a magnetic field always obeys a divergence free. It is divergence free always. But divergence of E is equal to rho, that is charge density, in the presence of charge density. But otherwise I have a E prime, which is divergence of E prime is 0. I have converted it. I have defined a new kind of an electric field, not necessarily what I measure. With the help of these mathematically defined electric field, divergence-less field, I will get what is called as a Helmholtz equation for the vector Helmholtz equation, like how we did earlier. We had done it already, right? Vector Helmholtz equation is known to us. I get a complicated right-hand side involving the source terms. Source terms means this magnetization, P of R, all those things appear. Similarly, for this the vector Helmholtz equation, left hand side is vector Helmholtz equation for E prime and B, but these things are complicated. I will not ask you to, I will not derive it, I will not ask you to remember it, but just check it once. That is, you should know that it can be done, it can be solved. So, but I will only write the equations like this, and then what I will do is to, after you see this, I will just say, fine, we'll go ahead now and see what needs to be done. Let me say, we then obtain inhomogeneous scalar Helmholtz equation. You remember, we had solved we had got a vector Helmholtz equation in the source free region. Then we converted it into a scalar Helmholtz equation, correct? Earlier. So I want to write a vector, so scalar Helmholtz equation for what is called as R dot E prime, like earlier. But this right hand side is complicated. I have complicated right hand side equation. So I will go ahead and check what is magnetic field. Again, this is a complicated right hand side. What was the earlier solution in the source free region? I want to ask you now because I want you to be with me. Iವಾಗ ಹೇಳಿ, this is, I will write del squared plus k squared into R dot E. What was it in the source free region? Can you tell me? ಈಗಲ್ಲ, ಒಂದು ಹಳೆ ಕ್ಲಾಸಲ್ಲಿ ಪಾಠ ಮಾಡಿದ್ದೀನಿ. ವಾಟ್ ಈಸ್ ಇಟ್ ಇನ್ ದಿ ಸೋರ್ಸ್ ಫ್ರೀ ರೀಜನ್? ಇದನ್ನ ನೋಡ್ಕೊಂಡು ಹೇಳ್ಬೇಡಿ, ಪಾಠ ಮಾಡಿದ್ದೀನಿ ಆಲ್ರೆಡಿ. ಡೋಂಟ್ ರಿಮೆಂಬರ್? ಸಿ, ಇಟ್ ಈಸ್ ಮೆಥಡ್ ಆಫ್ ಡೂಯಿಂಗ್ ಇಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅದಕ್ಕಿಂತ ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋಕ್ಕಿಂತ ಮಾಡಿರೋ ಮೆಥಡ್ ನೆನ್ಪಿಟ್ಕೋಬೇಕು ನೀವು. ಸೊ ದಿಸ್ ವಾಸ್ ಝೀರೋ. ಐ ಕಾಲ್ ದಿಸ್ ಆಸ್ ಹೋಮೋಜಿನಿಯಸ್ ಇಕ್ವೇಶನ್. Right hand side is 0 iddaga, it is homogeneous. Its name is called homogeneous scalar Helmholtz equation. Okay, I can't write it. Scalar Helmholtz equation. Scalar Helmholtz equation. Scalar Helmholtz equation. But now I am getting what is called as inhomogeneous. Inhomogeneous means these are inhomogeneous terms. That is, it is not 0. It is 0 only in the source free region. So same for magnetic field. We are solving the equations in the region where source is there. So I will check the solutions mathematically and then go ahead. That's what is the whole idea now. So let me say, if I do continue with this, though you don't need to remember, I will not tell you, you remember these things. So once I do it, I will say, fine, I neglect the contributions from polarization term. I neglecting the contribution of the polarization vector, I write it in this particular way. This you should remember. That is, I have a del squared plus k squared r prime r dot E prime of r, that is equal to some gamma of r, which is a function of r. Similarly, this is some lambda of r. If you don't have to remember, because I know that it is difficult to solve everything here. I will only tell you, fine, you can write, you need not write it. It involves a magnetization. It involves a current charge density, sorry, magnetization and current density, magnetization and current density in a particular way. This can be derived if you simplify it and keep on solving for 1 hour, but we don't want you to solve for 1 hour. Just memorize it if possible. Otherwise, say it is only a function of r. Then what I will tell you is, I want to solve these equations. Means what we say is r dot E prime. Okay, let me again now explain you Green's function method to solve inhomogeneous equations. What is it that I have been trying to tell you is, I am given a differential equation del squared plus k squared, and it is a it has a solution. Let us say some kind of a solution psi of r, that is equal to, I will say this is a f of r. Let us say some function of r. Then I will say, I already know what I know. I or we know that del squared plus k squared. This is a differential operator in general, but there is something called as a Green's function, g of r prime. This I know is given by delta r minus r prime. This is given to me. We know it. Then can I solve this equation? This is not known. Solution means what? I should give you psi of r as a function of r. What is known to me? F of r is given to me, but I want to find what is psi of r. Provided I know what is a Green's function associated with del squared plus k squared. Agandre, I know that g of r prime exists. There is a mathematical function. When you operate del squared plus k squared on g of r prime, it gives you a Dirac delta function. This should be known to you. In that case, what I will say is solution is then given by psi of r. I want to solve it. I will tell you that this is nothing but integral g of, okay, 1 minute. I will write it properly and then tell you. This is, you should know this. That is, I will write d cubed of r prime, some variation of integration, d cubed of r prime, g of r prime, and f of r prime. So this is what is the solution of our equation, is what I told you. Do you remember this? Last time, last class there. Now if you apply, this is solution. In terms of Green's function, this is known, f of r is known, f of r prime. R badlige r prime hakidre sari. Integrate madbidi. Then what you get is r prime is gone. After you integrate over r prime, you will get a function of r only after integration. Do you know that? I don't know what I should tell you, but let me ask you. Suppose I have a integral dx and I have, let us say, sine of x minus x prime anta ide. So now after you integrate, what do you get is what I will ask you. Namu gottidiyಾ idu prashne. What is sine of x minus x prime? You will write this as sine x cos x prime, and then you write minus sine x prime cos x. Integration ಮಾಡೋದು ಯಾವುದ್ರ ಮೇಲೆ? X ಮೇಲೆ ಮಾತ್ರ. So you integrate over sin x, what you get is a function of x prime. Okay, f ಅಂತ ಬರೆದ್ರೆ ಮತ್ತೆ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋತೀರಿ. Some function of x prime. What is that? Some g of x prime. Do you agree? All right, it may be cluttered for you. So what I am asking you is, suppose I give you dx prime, ಇದು ಬೇರೆ ಮಾಡ್ತೀನಿ ಇವಾಗ. Just tell me the correct answer. X minus x prime. ಇದು ಏನ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀರಾ? Will you calculate it and tell me? Do you know how to do it? Sin x cos x prime, one term, minus, tell me what is it? Sin x cos x prime minus, hello?
Cos x.
Okay. Cos x sin x prime.
Sin x prime.
All right. Integrate madi. Integration is with respect to x prime. So sin x is a constant. So you should write sin x cos x prime integration eno?
Sin x prime.
Okay.
Sin x prime.
Plus.
Okay, I should write a integration limit also. Say 0 to pi anta baritini. ಅದು ಬರಿದೇ ಇದ್ರೆ ಹೊರಟೋಗುತ್ತೆ. 0 to pi ಮಾಡ್ಬಿಡಿ. sin x prime ಬಂದ್ರೆ 0 to pi ಮಾಡಬೇಕು. sin 0 is 0, sin pi is 0, ಇದು 0 ಆಗೋಯ್ತು ಅಲ್ವಾ? Are you agreeing with me?
Okay, ma'am.
ಹೋಯ್ತು. ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ ಮಾಡೋಣ. ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ ಏನ್ ಬರುತ್ತೆ? cos x sin x prime ಅಂತಂದ್ರೆ ಮೈನಸ್ cos x prime ಬರುತ್ತೆ ಅಲ್ವಾ? ಅದು ಬಿಟ್ವೀನ್ 0 and pi ಏನ್ ಬರುತ್ತೆ? cos pi is -1.
-1 into +1.
-1 minus 1.
Min
-1 alwa. Upper limit minus lower limit alwa
Yes, ma'am.
integration alli.
Lower limit. Yes, ma'am.
Cos pi
-2.
minus cos 0 anta baribeku. Cos pi is -1. Cos 0 is -1. Cos 0 is +1. So it is -2. So what is the result? I get 2 times cos x anta bantu. So result is 2 times
Yes, ma'am.
cos x. Everything that you do
Correct.
in physics, they have mathematical equations. So what I have shown you is, if you have a function, if you have sin x minus x prime dx prime with the integration limit given to you, what is it that you get? This is a function of only x. There is no x prime after integration, correct? So I am as telling you a method of solving integrals. So a method is, if I have, suppose I have del squared, again repeat, del squared plus k squared acting on a function, some function. I am calling it a psi. Adu quantum mechanics alla illi. Yavado one function, some psi is equal to, let us say, some gamma of r. Anta ide. Solution to this equation. This is called as a scale inhomogeneous scalar equation. Inhomogeneous scalar Helmholtz equation. This is called an inhomogeneous term, inhomogeneity term. So solution of this is phi of r is equal to integral antandre r cubed, all the integration of d cubed r prime, and I write a g of r prime, that is Green's function associated, multiplied by gamma of r prime. And I told you there is an integration over r prime. What remains is a function of r, and that is our solution. If you have a Green's function, if you have a gamma of r given to you, integrate over it, you will get a solution of this equation. Any differential acting on this is giving you gamma of r. What is the solution? Solution is given by this kind of a equation is what we are telling you. How am I saying that? Let me tell you now. Why am I saying that? So if you take a psi of r prime, I am repeating it because I know it, you won't be able to remember it in the last class what I told you. D cubed r prime, g of r prime multiplied by gamma of r prime. That is what I have told you. Now let us apply. This is my equation 1. Let us apply del squared plus k squared acting on psi of r. What is this equal to? So this is equal to del squared plus k squared. I am claiming that this is del squared plus k squared d cubed r prime and g of r prime multiplied by gamma of r. So now integration is with respect to r prime. R is a constant. As far as integration is concerned, r part cannot be touched. So I will say this is d cubed r prime and gamma of r prime. Then I am taking this inside. Del squared contains a dou squared by dou x squared, dou y squared, dou z squared. Integration is with respect to x prime, y prime, z prime. So this can be taken inside and it goes and sits on wherever you have a r. R prime irli, but idನ್ನು differentiate ಮಾಡಬೇಕು. Do I know what is del squared plus k squared acting on g of r prime? Anybody? Do I know it or not ಅಂತ ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ನಿಮ್ಮ ಹತ್ರ ಪ್ರಶ್ನೆ ಕೇಳಿದ್ರೆ ಅಯ್ಯೋ ಉತ್ತರ ಹೇಳದೇ ಇದ್ರೆ ಏನ್ ತಿಳ್ಕೊತಾರೋ ಅಂತ ಯೋಚನೆ ಮಾಡಬೇಡಿ. Just tell me, do you know what is del squared plus k squared acting on a Green's function? ಗೊತ್ತೋ ಇಲ್ವೋ ಅಂತ. Do I know it?
No, ma'am.
delta r minus.
I told you it's a Dirac delta function. ಅದು ಗೊತ್ತು ಅಂತ ಹೇಳಿದ್ದೆ. If I know this acting on g of r prime, that is what is given by, I know this idana integral d cubed of r prime and lambda of r prime And this is known to me. I am using it and writing this is delta r minus r prime. So after I write it, I will erase it because there is no place. I had told you earlier, last paragraph, last slide, that I know what is a property of a Green's function. Green's function property is given a differential operator. ಇದಕ್ಕೆ ಒಂದು Green's function ಇದೆ. That is equal to delta r minus r prime. ಅದು ಗೊತ್ತಿದೆ ನನಗೆ. ಆವಾಗ I want to solve inhomogeneous equation. ಇಲ್ಲದೆ ಇದ್ರೆ ಮಾಡಕ್ ಬರಲ್ಲ. Green's function method is used to solve inhomogeneous equations when I know what is the solution of a homogeneous equation. ಅಂತಂದ್ರೆ ಇದು ಗೊತ್ತಿದೆ ನನಗೆ. Green's function is a solution of this equation. ನಿಮ್ಗೆ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಕೊಟ್ರೆ ಇದು ಸೊಲ್ಯೂಷನ್, ದಿಸ್ ಇಸ್ ಎ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ದಿಸ್ ಇಕ್ವೇಶನ್ ಅಂತ ಗೊತ್ತಿದೆ. ಅದು ಗೊತ್ತಿದ್ರೆ ಇಫ್ ಐ ಸಾಲ್ವ್ ಫಾರ್ ಗ್ರೀನ್ಸ್ ಫಂಕ್ಷನ್ ಐ ವಿಲ್ ಯೂಸ್ ಇಟ್ ಫಾರ್ ಬೆಟರ್ ಅಪ್ರೋಚಸ್. ಬೇರೆದಕ್ಕೆ ಉಪಯೋಗಿಸ್ಕೋಬಹುದು. ಒಂದು ಗೊತ್ತಿದ್ರೆ ಇನ್ನೊಂದನ್ನು ಸಾಲ್ವ್ ಮಾಡಕ್ ಉಪಯೋಗಿಸ್ತೀನಿ ಅಂತ. ಇದು ಗೊತ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇವಾಗ ಐ ಹ್ಯಾವ್ ಗಾಟ್ ಇನ್ ಮೈ ನ್ಯೂ ಇಕ್ವೇಶನ್. ವಾಟ್ ಈಸ್ ದಿ ಇಕ್ವೇಶನ್ ದಟ್ ಐ ಹ್ಯಾವ್ ನೌ? Now what I have is, if I have this, then what is the result of this equation? ನಂಗೆ ಗೊತ್ತಿದೆಯಾ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಕ್ ಬರತ್ತಾ ನಂಗೆ? Do you know what is gamma of r prime? Delta of r minus r prime. Okay, I will ask you a question. If I give you integral f of x prime delta of x minus x prime dx prime, ಇದು ಗೊತ್ತಾ? ಇದು ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಎ ಡೆಲ್ಟಾ ಫಂಕ್ಷನ್. ಇವಾಗ ಡಿರಾಕ್ ಡೆಲ್ಟಾ ಫಂಕ್ಷನ್ ಇದ್ರೆ ಇಫ್ ಯು ರೈಟ್ ಎ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಮೈನಸ್ ಎಕ್ಸ್ ಪ್ರೈಮ್ ಡಿ ಎಕ್ಸ್ ಪ್ರೈಮ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಪ್ರೈಮ್, ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಆಫ್ಟರ್ ಇಟ್ ಇಂಟಗ್ರೇಷನ್. ಗೊತ್ತಿಲ್ವಾ ಅದು? ಹಲೋ? These are all done in mathematical methods earlier so that you can come to third semester to do your third semester classes. ಈಗ gamma of r prime delta of r minus r prime ಅಂತಿದ್ರೆ it is going to be simply gamma of r. Integration over r prime ಇದೆ, delta r minus r prime ಇದೆ. So whenever, only when r is equal to r prime, delta function gives you the result. When r is not equal to r prime, delta function is 0. So integration nalli only when r is equal to r prime you get the result. So what did I get now? What I got now is, il barilik agalla, so I have to erase and write it. Del squared plus k squared acting on psi of r is equal to gamma of r, implies that psi of r is equal to integral g of r prime gamma of r prime. ಇಲ್ಲೇ ಬರಿಬೇಕಾಗಿತ್ತು ಬಟ್ ಕೊನೆಯಲ್ಲಿ ಬರಿತೀನಿ, ಪರವಾಗಿಲ್ಲ. d cubed of r prime. That is the solution. Psi is called a solution. Gamma r is given and I know the Green's function. So ಆವಾಗ ಈ ತರ ಬರಿತೀವಿ ಅಂತ ಒಂದು ಗೊತ್ತಿದೆ. So now I will repeat it again. So what I am trying to say is Green's function method can be used to solve our equations. So we express the solutions of the inhomogeneous scalar Helmholtz equations. R dot E prime and R dot B in terms of the corresponding Green's function. R dot E prime andre what I wrote as psi of r and bardidnalla, that is R dot E prime of r. Solution is given by G of r prime into gamma of r prime. Similarly, R dot B of r, adralli gamma of lambda of r prime antittu. So I will write this. I hope you are able to understand. If you don't, then please ask me. So right now I will continue. Method is important here. Solutions ginta method of doing it. Adu ನೀವು connect ಮಾಡ್ಕೋಬೇಕು every time. So if I say that I know the Green's function associated with scalar Helmholtz equation that is given by this anta yaro ಮಾಡಿಟ್ಟಿದ್ದಾರೆ, we need not solve it. This is a function of both r and r prime. R ide, r prime ide. G of r prime is given by this, and this obeys. Green's function is defined by this equation. And if you substitute this, you will get a delta function anta noditidare yarono. We are going to use it. If we get the Green's function, then what is our equation there? Our equation is going to be, it's not moving. 1 minute. Why is it not moving? All right. So this is our equations, and I know the Green's function, so I am writing the solutions. Just so I have written the solutions. That's what I was telling you a story. If you get used to it, then you know this is the way I can solve. I can integrate. I know integration. I know Green's function. I know lambda of r prime. So I will integrate it to obtain. What is our aim here? I want to obtain what is E prime, what is B, so that I can talk about solutions. Solutions of our electric field and magnetic field in the region of the source. ಅದಕ್ಕೆ ಮಾಡ್ತಾ ಇದೀವಿ. So once I get this, let me just tell you. So after I get the solutions, I am going to tell you that I have r dot e prime known now. ನಾವು ಸಾಲ್ವ್ ಮಾಡಿಲ್ಲ, ಇವಾಗ ಮಾಡಕ್ ಆಗತ್ತೆ ಅಂತ ಮಾತ್ರ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. I get r dot e prime, I get r dot b after I integrate. Then some people tell you, suppose I talk about some regions, that is I am giving you e prime, let us say e prime of r ಅಂತ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. e prime ಹಾಗೇನೆ b of r ಕೊಟ್ಬಿಡ್ತೀನಿ ನಿಮ್ಗೆ. ಕೊಟ್ರೆ I will ask, this is not easy to write solutions. ಮೊದಲೆಲ್ಲ ನೀವು ಸೊಲ್ಯೂಷನ್ಸ್ ಅಂತಂದ್ರೆ ಎಲ್ಲಿ ಬೇಕಿದ್ರು ಕೊಡ್ತೀನಿ, ಸಿಂಪಲ್ ಇಕ್ವೇಶನ್ ಇರ್ತಾ ಇತ್ತು. This is a complicated kind of a differential equation. So once I give you, I will have to split it into different regions. One region is called k into r is much smaller than 1 ಅಂತ ಒಂದು ರೀಜನ್ ಇದೆ. ಅದನ್ನ ನಿಯರ್ ರೀಜನ್ ಅಂತ ಕರಿತೀವಿ. ನಿಯರ್ ರೀಜನ್ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಸೋರ್ಸ್ ಇರುತ್ತೆ ಅಂತ ಅನ್ನೋ ತರದ ರೀಜನ್. ಅಲ್ಲಿ ತಗೊಂಡ್ರೆ I do get what is our solution. AE of LM, AM of LM ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. I am just writing it. It looks complicated, but unfortunately you have to memorize this. Why? I will tell you. So if what is the source dependence of the amplitudes ಅಂತ ಬರ್ದ್ಬಿಡ್ತೀನಿ ನಾನು. ಇದ್ರಲ್ಲಿ ಏನ್ ಗೊತ್ತಿಲ್ಲ ನನ್ಗೆ ಅಂದ್ರೆ what is QLM, what is Q prime LM ಅಂತ ಹೊಸ ಡೆಫಿನಿಷನ್ಸ್ ಇದೆ. So I have to keep repeating this so that it will get back to you. So I am going to write this. Let me tell you the logic. If I know what is the electric field, let us say electric field is known as a function of R. I know the magnetic field as a function of R. These two together define my gamma ray or any electromagnetic radiation for that matter. For all R, I am taking R such that magnitude of R, I call it as R, and its energy, wavelength of the wave number of the radiation, I call it K. Kr is much less than 1 ಅಂತ ಅನ್ನೋ region ನಲ್ಲಿ I will write this solution. Whatever is the solution. What is that I am going to get? Let me tell you. What I get with that region is E of R such that Kr much less than 1. I am going to get AELM and EELM of R plus AMLM, EMLM of R. ಈ ತರನೇ ಬರುತ್ತೆ ಮತ್ತೆ ಸೊಲ್ಯೂಷನ್ಸ್ ವೇರ್ LM ಮೇಲೆ ಸಮೇಷನ್ ಇರುತ್ತೆ. ಏನು ಬೇಡ ನಮ್ಗೆ, ಬಟ್ I do get a AELM, AMLM in this region. Then do AELM and AMLM, they depend on R? I told you earlier in my solutions, these
No,
are
ma'am.
only coefficients. They do not depend. But I am determining what is the dependence by appealing to Kr much less than 1. So what I am trying to tell you, it's a complicated thing, but you should only understand the methods of doing it. The method of doing it indicates that I can determine the source dependence of the amplitudes. So I want to do that. Let me just move it once. And my idea is to say I am able to determine what is the source dependence of this. That is given by this complicated expression. But what I want to tell you is, all right, you have got this. We will go ahead and show you what is this QLM and Q prime LM. So this Q prime LM and QLM, they are called electric multipole moments and magnetic multipole moments. That is what I'm going to recognize, and I will tell you what is electric multipole moment. Okay, I'll just tell you. Electric multipole moment QLM, this is equal to d cubed r integration over rho of r. Do you know this? We know charge source. Source means charge density is known. If you take an integral like this, what you get is called as a multipole moment. You have done it in your electrodynamics when you did multipole expansion. Did you do it or no? You've done it, you have forgotten. But if you take this, what you obtained is called as a multipole moment. How did you do it? Let me remind you again. See, please be with me. Suppose I have a charge distribution here. I have a charge distribution. Just okay. Here, I am standing here. I am an observer. I want to explain how does this charge distribution looks like. Then I will write this charge distribution. It is looks like a monopole. Some coefficients are there. Say A0 monopole plus A1 into dipole. What is a dipole? It looks like two charges separated by a distance d. So it looks like a dipole with some parts of it. And then it looks like a quadrupole. So we have an expansion like this far away. That's what is called as a multipole expansion. So what I am trying to tell you now is, in your what is AELM, it depends on QLM and what is called as Q prime LM. That is new to you. I will try to explain. So this depends on the source. How does the source look like? It has all multiple moments. Your AELM, amplitude of your expansion, it depends on source through QLM. So that QLM is an integration. After integration, it's a constant. That number is what is given by QLM, is what I say. So now with that, right now you can only take a look at these things, but don't try to get scared. Don't get scared. But I'm just writing what is QLM definitions in electrodynamics. These are definitions. I will tell you when you need to remember it, but I have sympathies with you. These are to be just seen once. That is what I have. So then I will ask you what you need to remember gradually when we go ahead. So once you have this, I am just going to tell you that fine, we have it. Let us take a special case of L equal to 1, M equal to 0. This is called dipole. Dipole moment. L equal to 1 is a dipole. So correspondingly, what I have is Q10. You can see that Q10 is d cubed r. I have to substitute what is Y10, that is proportional to cos theta. So you can check that. It's tough to explain. If it is on a board also, it is tough to explain, but I will try here. Here I have a QLM, full QLM. Substitute L equal to 1, M equal to 0. What is L equal to 1? R to the power L, R is there. YLM star theta phi, this is a cos theta when L equal to 1 and M equal to 0. And there is a overall factor there. I will write it. This is d cubed r cos theta and a charge rho of r. What is r cos theta? That is nothing but z. Correct? It is r cos theta is z. And I have a rho of r. This is what I am going to get for Q10 is proportional to this. That is what I am writing in the next page. I will stop it here, but let me just come to a conclusion. This is enough for today. So Q10 is Z rho of R. Similarly, I will find, I am not able to show it to you, but I will just tell you what is important. I will tell you later on. But right now what I have is M10 magnetic moment is R cross J. That is what I will get. Now I want to tell you some physical significance of this. So dipole moment is containing Z into rho of R. If you remember, how do you define your dipole moment? Two charges are there. There is a distance, let us say D, and charge is plus Q and minus Q. Then you define dipole moment as Q into D, that is the magnitude of the dipole moment. Similarly here, instead of Q, you have a rho of R. D is distance Z, and integration, that is sum of all such things. That is what is a corresponding generalization of dipole moment. So I have dipole moment analogous to that. So I'm just reminding you, then magnetic moment is given by this. So what I will tell you now is, fine, we have got this. Then I want to show you that it may be seen that magnetic dipole moment contains a current density J, and current density is related to charge density through J is magnitude wise, J is charge density times velocity, speed of the particle. So that is, it is kind of magnitude of V. So I hope you know this. Current density and charge density are always one. Velocity of the current is charges moving gives you current. So charge moving is rho multiplied by V is called current density. So V denotes the velocity. We find that, fine, we have probabilities. Okay, this is tough to tell you. So if I take electric AELM, it is proportional to QLM. AMLM is proportional to MLM. Let me just take it like this. For what I have as L equal to 1, M equal to 0, 1, 0, I have what is called as 1, 0, Q, 1, 0. Similarly, here, this is 1, 0. This is 1, 0. So what is Q10? It is proportional to, I will again say that Q10 is proportional to what is called as rho here, density, current charge density. M10 is proportional to velocity into rho. I am just writing it. So AE10 divided by AM, oh sorry, AM10 divided by AM10 divided by AE10, let me say mod squared, is proportional to V squared divided by C squared is what I get. Here it is, there is a C also. So I am just trying to highlight this throughout. After all that, what I am doing is AM mod squared of the amplitude of magnetic moment, magnetic multipole radiation is V by C whole squared of electric transition. So what I am trying to finally tell you is magnetic is smaller compared to electric. This result holds good for multipole moments of higher order too. That is, probability of magnetic multipole radiation is smaller compared to that of the electric multipole radiation of the same order L. If you remember, I had mentioned it during my selection rules. Okay, this is all that I have today. What I have been trying to tell you is, you have a solution of the magnetic field, electric field, and then you are trying to get solution. Nature of the solution is what is important. That is, a solution qualifies to be called as an electric type or magnetic type. That is what you have learned. If it is an electric type and magnetic type, which is dominant, electric type is dominant than magnetic type. These are qualitative results, but you wouldn't have got it if you did not solve it completely. Completely solving it in examination is tough. So we will give you what is a solution, nature of the solution. In between, little bit of derivations here and there, we will ask you to derive that. But what is the lesson that you have learned finally is electric multipole radiation. A source emits a radiation which is electric type or magnetic type can be understood. Electric type radiation of multipole order L is dominant compared to magnetic type multipole radiation with L value, same L value. That's what is the lesson of whatever I have told you today. After all that mathematics, this is what I learned. If I did not do mathematics, I would never learn it. That's the idea. Okay. So I will give you some questions. Don't get scared by looking at the expressions. What you should know is what I will give you as a set of questions that I will do in the next class. So this is the end of classical analysis of electromagnetic radiation, which is emitted by a source, which gives you definite energy kind of radiation. So that is done. But I have a radiation which is coming from a quantum mechanical source. Nucleus is quantum mechanical. How am I going to generalize it? There is a discussion on how I talk about all these things. If nucleus I know is quantum mechanical, how am I going to talk about it? That is what is an indication. Again, you have to learn what is the lesson learned at the end of the story. But story is little bit you should know. So that is what I will try in the next class. Okay. Are you getting scared with